Today we are presenting International Webinar on Data Science by Dr. Arasu Narayan, Principal Data and Applied Scientist, Microsoft from USA. It is organized by Department of Computer Science, Nansal Catholic College, Kaliyakavalai. Now I request Mr. Abhilal Sam Austin to deliver the welcome address.
Good morning to all. Today we are connected here to discuss about a very important topic, data science. So we organize an international webinar on data science with an excellent resource person. First, I heartily welcome our secretary, the Reverend Father M. Eckermans Michael. In this prestigious moment, he has given constant support and motivation to conduct this international webinar. I feel privileged to extend my warm welcome to you, Father. Next, I would like to welcome our respected principal, Dr. Meenakshi Sundararajan, who has helped us to organize this webinar. He is the key person of this event because he has taken more initiatives to conduct this event. Welcome you, sir. Next, I wish to welcome our resource person, Dr. Arasu Narayan, who is working as a principal data and applied scientist from Microsoft, USA. He is a man of a rich profile. He started his career as a software engineer in the year 1997. By his hard work, he has flourished as a team leader, project leader, data modeling engineer, database engineer and analyst, senior applied data scientist, and so on. We are very happy and lucky to have such a great resource person like this. I welcome you, sir. Next, I am very happy to welcome all my department colleagues who has taken part in this event. Finally, I would like to welcome all the participants who has actively participated in this webinar. Some participants from across the country. So I welcome all the participants. And I welcome you all once again to the webinar and hope that you all will have a great time ahead. Thank you.
Thank you, sir. Now I invite our dynamic principal, respected Dr. A. Meenakshi Sundararajan, to present inaugural address.
Good morning to each and everyone, dear participants. Most respected Secretary of our college, Reverend Father M. Eckermans Michael, Head Department of Computer Science, Professor K.C. Abhilash, Department members, and sir, we are really fortunate to have such talented resource person this dear participants. He is a we can teach theories, but how to implement the what we want to. But Arasu is a practitioner, vast knowledge about the data. Now you know the data is a topic and apply data is a topic. For example, you look SAP SAS. SAP and SAS is using for analytical purposes. SAP is using for commerce. SAS is using for medical softwares. In India and throughout the world, data mining is there is a great demand for the scientists of computer science, especially for data mining. You should be specialized in SAP or SAS. It will be very helpful to get a appointment. I think the talk given by Dr. may be very helpful to the participants. I Dr. Arasuna, you for the fact really participants registered. So on behalf of my sincere thanks to Dr. Narayana. My friend Dr. He is the of his college. He introduced me to our college and our HOD of arranged this seminar, international seminar. So my sincere thank you, HOD, Dr. Thomas, Raji, and Aranya, all faculty members for my sincere thanks. Thank you, one and all. I think the seminar will be helpful. Thank you very much.
Really, it was an inspirational talk. Thank you, sir, for your sharing and great knowledge. Next is technical section. Before we go further, I want to review the functionality of webinar. If you have any questions during the presentation, please type them in the chat box, and we will also have time for questions at the end. Now I introduce today's presenter, Dr. Arasu Narayan. He is a principal of data and applied scientist, Microsoft from USA. He is familiar in data science and research. Now I hand over the section to our resource person.
Okay, can you able to hear me? Yeah, can you able to hear me?
Yes, sir.
Okay, fine. All right. I think if others, I think mute your mic. That would be great. Okay, all right. Just I think just to give some small introduction about myself. What is my passion and all about. I think already there are a few of them introduced about me. Then I have a few master degrees in the computer science. I have a master degree in computer science, then operation research and data science. I think recently I finished my PhD in natural language processing, that is the AI space. So I have been in this industry for more than 2 decades. So I have been with Microsoft since 2005. I think I have been in Microsoft as a data scientist since 2015. So for the past 5 years, I think I'm working here as a micro data scientist. And most of my career, I did product development, then application or some service-based development. I got a chance to work on various supply chain systems, customer relationship model, products, and I think I worked on most of the product team inside this Microsoft. So then my main area of focus or my area of interest is on the natural language processing, statistics, machine learning, and deep learning. That's all about me. Today, our agenda is, I think, first we will go through the data science. What is the data science? Just introduction. Then we'll go through the difference between data science, machine learning, and AI. What are those three terminology and what is all about? Then the various algorithm used in the data science space. I think we are not going to touch everything, but we will go through the common algorithm in the data science space. Then data science life cycle. How is this a data science life cycle when somebody started a data science project? How this data science life cycle is look like? Then what is the current trend in the data science space? So how to build a data science team? What are the various roles will be there on the data science team? And what kind of thing, if you explore yourself as a data scientist, I think what kind of job opportunities and how much you can make as a data scientist. Those are the few things I will walk through. Then finally, I have 10 minutes question and answering time. If anybody has some questions, I think please discuss at the end of the session. Okay. Now let me discuss about the data science. I think we are talking about data science. What is exactly this data science? Before we talk about data science, I think we might had about the terminology called data mining, predictive analytics, statistics, data analytics, some data science, artificial intelligence. I think what is exactly this? I think is data science is something different from these terms, or it's a combination of all the terms. So we should, I think, when we somebody talk about data science, we might scratch our head and ask all by ourselves, what is exactly this one? I think why don't we study this one? All the questions will be raised by ourselves. So if you answer this for this, I think we can say that what is exactly this. This is not exactly a data mining or data analytics or data statistics. This is a combination of everything. So what is exactly, I think you can say as a data science is we are extracting some knowledge from the data. So we might collected various type of data. The data might be in terms of text or image or audio or some where we might kept it in the database or some big data environment. I think the data is sitting everywhere. So we trying to extract some knowledge out of that data. That is, I think, one we called as the data science. So for that, what are the things we need to have? This is interdisciplinary role with the combination of mathematics, statistics, and computer science. So that is the knowledge you should have if you want to work as a data scientist. Okay, so then next we will see where this data is coming from. What is exactly this data? So we might have about this word term called big data. What is exactly this big data is all about? So this big data is all about I think three properties or three attributes we can provide as a big data for a big data. So the first one is a volume. I think second one is velocity and variety. So what is exactly the volume? In our organization, they are collecting the data from variety of sources. That will be in terms of business transactions, like a bank transaction or a retail store transaction or any IoT, Internet of Things, or any sensor devices, or social media. This data is coming from variety of, I think various sources. Then when we collect all this data, the volume of data is very high. So, however, I think we are collecting all the data. When you go to Facebook or when you go to any social media, Facebook or Twitter or Instagram or LinkedIn or any social media. I think best example we can talk about. I think everybody these days are using the messenger services called the WhatsApp. The WhatsApp or anything, we are having tons of images, text, audio, document. We are sharing each and everything through this platform. Where do they keep this data? They're keeping the data and storing the data in the big data environment. Then what is a velocity? How fast I think we are getting the data and capturing this data. I think that is called as the velocity. So velocity is the measure, or velocity is it's a quantifier of how fast our data is coming. So that is the way we can quantify the velocity. So for instance, in the Facebook has to handle some, what is it, I think kind of a tsunami of photographs or tsunami of video, or thinking a lot of people are going and checking likes, dislikes, or they go and add some comments with this others post or others image, or I think if somebody is asked some questions, they are posting their answer there. So for each and everything, the volume of data is coming in a second actually. So each and every second, I think Facebook or any social media, they are getting around terabytes of data. So how we are measuring that incoming data, that is called as the velocity. Then what is exactly the variety? Variety, as I mentioned earlier, this will be the several formats of data we are getting from these social media or any platforms. I think it will be a social media, or it will be any transaction systems, or it's the retail systems like a Flipkart or Amazon or any other retail online retail platforms. Or I think if you go to LinkedIn, or if you use any mail systems or messenger system, any systems, I think what we have, I think different type of data. I think that will be structured. When I say structured, I think we may go and store the data directly to the relational database or some document-based databases. Some cases we may get this data as an unstructured format. Unstructured format means the data will be in terms of free text format. We may store the data as some I think like a newspaper or any free format. Then whoever wants the data, they used to extract the data and get some juice out of this data. So that is the task actually we will do when we are doing any data science activities. So then emails or videos or audios or some systems has some log files. Log files means log files will talk about I think what type of users logged in, what time they logged in, what time they logged out. I think all those information, I think we may capture in the big data environment. These are the three V's, or the three properties I think we are talking about in a big data. Okay, now I think you can raise the question. So we collected all this information. What is the use of collecting all this information? What we are going to do? I think if you are not doing anything with this data, it doesn't make any sense. I think what is the use of Facebook or any of these companies like Facebook or social Skype or Instagram or the LinkedIn, I think Spotify, all these social media companies, I think what is the use of spending this money and capturing this data? So that is, I think, doesn't make any sense. So first, we should answer what we have to, what, why, and how. What we have to do with this data. I think why we collected all this information. How to get some information out of this data. So for all these questions, we have to answer through this data. Sorry. So we are collecting, I think, the information every year. So for example, in the 2025, we may end up with, I think, around 200 plus, I think 200 zettabyte. Zettabyte means that is, I think, 10 to the power 21 bytes. I think that is next to, now I think everybody know about what is gigabytes. After gigabytes, we have terabytes, petabyte, then exabyte. After that, I think the zettabyte will come. So we may collect around 200 zettabytes of data. We are going to collect it in the big data environment. So that is not far away, another 5 years. I think right now we are handling all the data in terms of petabytes and exabytes. So another a few years, we are hitting high volume of data. So now you can ask the question by yourself, are we using all this data? How much data we are using in the real time? I think if it is a Facebook or Microsoft or Google or Amazon, are they going to use all this data right now? How much data they are leveraging? So what is the what they are doing this rest of the data? So if you ask these questions, think we are leveraging around 5% of this, sorry, 0.5% of this data out of the what I think the 100 betabytes or exabytes data what we collected. So that means around 99.5% of the data what we collected was never used, or it is, I think, staying on the data center. So just we collected this data, and I think all this management, all this business, what they are thinking is we may use this data in sometimes later, so that we can get some business insights or some business rules, how to drive this business using this data. We may come up with this, all this information probably in a year or 2 years later. We may get something from them. That is the long-term roadmap or long-term goal for all these countries, so all the bank application or any retail application or any transaction in the production system or the